the next thing we're going to look at before we get into some translations of the sine and cosine graphs is to look at solving trigonomic equations. So this is the next part you can see in your notes. Okay, now I've put this here so that you can refer back to it. Okay, it's obviously because you haven't done anything yet, it's not going to make a lot of sense, but just to come back to it. So when we're solving equations involving trig functions, there are a number of things to think through. Now, essentially what we're doing when we're solving trig equations is that we're finding the angles that make a particular equation true. Okay, so first of all, we need to determine the domain over which the solutions are to be found. And now this is important because, as you know, it's a periodic function and we could go around the unit circle an infinite number of times, and so there's essentially an infinite number of solutions. But if we restrict the domain, then there's going to be there's going to be a limit on that. Okay. The next thing to do is to, once we've identified the domain, is to rearrange the equation if necessary. The second thing to do is to rearrange the equation if necessary, to put it in the form sine of whatever's in the brackets equals b. So that just means sine or cosine something or tan something is equal to a number. So there'll be a bit of rearranging often that's necessary. But we just want to get it into that simple form. We've just got the sine function on one side and we've got a number on the other side. And that will help us to simplify things. Okay. Now, it says here in more complicated equations, the unknown t, which might be theta or it might be x, it's not always a t, okay, but the unknown will be locked within an expression, okay, in an expression, so it might be, say, 2t plus pi or something like that, and that will be inside these brackets here. Okay, so looking for the domain, rearranging if necessary. Thirdly, determine the basic angle, which is the equivalent first quadrant solution. Okay, so I refer to it as a basic angle. It's just an angle that's between 0 and pi on 2, or 0 and 90 degrees. Okay, so that's the first thing. It's just like, what is the most simplest solution, which may or may not be part of the solutions. But once we've got that, then we can work out the actual solutions, because the next thing we need to do then is to look at what quadrants the solutions are going to be found in. Because remember, sine, cosine, and tan, they're positive in certain quadrants, they're negative in certain quadrants. So we need to think, which quadrants are the solutions going to be in? And then lastly, find all of the solutions that is within the specified domain. So we're just going to start with some really basic equations. Okay, so example 7. Solve the following equations for the unknown angles. Okay, so what we've got here is sine theta, sine of some angle, is equal to 1/2. So we want to find out what is this angle or angles. So there may be one, there may be more. It depends on the domain. Okay, so we've got here, this is our domain. Okay, so we're just looking to find the angles within the range of 0 to 2 pi radians. Okay, so we can see, because it's in terms of pi here, our solutions are going to be in radians rather than degrees. So we don't need to do any rearranging. It's already in that form that I spoke about, where it's just sine of the angle is equal to some number. So that doesn't need changing. It's just, we just need to find out what the angles are. So then a couple of things that we need to identify, and it's worthwhile just writing down here. I tend to, as a first step, is just draw a unit circle, and think, okay, which quadrants is my solution going to be in? Okay, so sine of the angle is a half. Now, what I need to look for is this number here, is it positive or negative? That's the first thing, okay, that I look at. Now, being positive, I think, okay, which quadrants is sine positive in? Okay, it's positive in the first and in the second quadrant. So I know my solution is going to be here and here in the first and second quadrants. So I have my basic angle, which is always in the first quadrant here. So I'm just say theta. And this quadrant here, okay, I find my angle by going pi minus my basic angle theta. Okay, so the basic angle is equal to what? Well, I need to refer to, if I can, my exact values table. So I refer to my exact values table so that I can find what is the angle for which sine is equal to 1/2. Okay, so what I'm going to do then is refer to the exact values table on the information sheet. So I'm going to go through. So this is information sheet you would get in the exams or any tests that I give you. And here's our exact values table. Now, we said that sine of our angle is equal to 1/2. So here's sine, here's 1/2. This is my basic angle, okay? So these basic angles are all what we're interested in, okay? Because these are within the first quadrant. And so sine of pi on 6 is equal to 1/2. So this is my basic angle. Okay, so I write down pi on 6 is my basic angle. Now, as I said, this basic angle may or may not form part of the solutions in any given question. In this case, it is because our solutions will be in the first quadrant and also in the second quadrant. So theta is going to be pi on 6 and also pi minus pi on 6. And so we simplify this one. So we usually just separate our solutions with a comma. That is fine. Okay, so we've got pi on 6 and 1 pi minus pi on 6. Now the easiest way to do this, I find, is just to change my pi into a fraction over 6. So 1 pi would be the same as 6 pi on 6. So 6 pi on 6 minus 1 pi on 6 is 5 pi on 6. So, and that's starting here at 0, going once around the unit circle from 0 to 2 pi, which is what the domain's required. And there's no solutions in the third and fourth quadrant because sine is negative there. And here we could see that sine of the angle was positive 1/2. So our solutions are only in these two quadrants. So with only once around the unit circle, you would expect there to be two solutions. Okay. In this case, there is. These are the two solutions, and that's it. Okay, so let's have a look then at our next example. We've got cos of t is equal to negative 0.7. Okay, and our domain is stated slightly different here. So in the previous one, our domain was written like this: theta is an element or as a member of the interval from 0 to 2 pi. This one here, written a bit different, t is between 0 and 2 pi. Okay, again, same thing really, it's just once around the unit circle. So let's look at what we've got. So here's our unit circle. Now our basic angle is always in the first quadrant here, but notice here that our number that we've got is negative. Okay, so that means our solutions for cos being negative will be in the second quadrant and third quadrant. Okay, but we still need to work out what our basic angle is. Basic angle, BA, in this case, now notice 0.7, that's not one of these nice numbers that we have Whoops, going too far. Here we go, methods for information sheet. These are our nice basic angles in the exact values table, but there's no 0.7 here. So whenever you've got a decimal number like that, we can't really refer to the exact values table. So what we do then, in this case, is to actually go, what angle, so we do the arc cos, it's called arc cos or inverse cos function of 0.7. Now don't put in negative, okay? Whenever you're working out your basic angle, you just ignore the negative and you just look at the number itself, okay? Because it's just the first quadrant solution we're after, okay? So just using your normal scientific calculator, you can do the arc cos or inverse cos function of 0.7. So if I do that on my calculator, I go shift cos to get my cos -1 there. That's the inverse cos of 0.7. And yes, now on my calculator, I've brought up 45.57 degrees, but of course that's in degrees. But notice here that our angle is in radians. It's in terms of pi, so it's in radians. So I just need to change my calculator to be set on radians and do the same thing, and it gives me 0.7954 to 4 decimal places. Okay, so if we just put it to 4 decimal places, well, 4 significant figures, whatever, it doesn't really matter. It's not specified in the question. Okay, so I've just got it there as that. That is our basic angle in radians. Okay, so then our angle T, second quadrant, remember, is pi minus our basic angle. Third quadrant is pi plus our basic angle. Okay, so we've got here then, it's going to be pi minus 0.7954 and pi plus 0.7954. So on the calculator, that comes up as 2.346 radians and 3.937 radians. Okay, and that's done. That's our two solutions. Again, once we're in the unit circle, we expect two solutions.